Welcome back to this channel. In today's video, we are going to be dealing with the weight of a body in a lift. So if a body were to be in a lift and the weight were to be taken, these are the possible conditions that might arise, and there are 5 possible conditions. Now, the first one is this. And now, first, we must understand the notations. So after understanding the notation, then we'll deal with the equations. So the first thing is we have F net, or let's call it the weight that will be recorded. So that is F recorded. Let's name that FR. In your textbook, you see just F. Is that okay? But like F recorded, that will be recorded on that weighing balance. And also there is your normal weight, W, which is the force of your mass times acceleration due to gravity. All right. So then there is also acceleration due to the force that is acting on the body. So within in the lift system. All right. So the first condition is this. So we said that there are 5 possible conditions. So the first condition is this. The first one is if a body is in a lift, for example, so you have this body in a lift. There's a lift, and the lift was going upward or downward. But this condition one. If the body is going upward or downward with a uniform velocity, if the body is going upward or downward with a uniform velocity, what does that mean? It means that acceleration, there is no acceleration. Acceleration is 0 because acceleration is changing velocity here. So since the body is moving with a uniform velocity, then it means that it has 0 acceleration. So because of this, the weight that will be recorded, the FR will be equal to the exact weight of the body if it were to be on the normal ground, if it were to be outside of the lift. So the weight of the body, F recorded, will be equal to the weight of the body, which is what? Mass and acceleration due to gravity. So that's the first condition. Understand that if the lift were to be moving with a speed upward or downward, so this is not just it is not directional. It is both whether it's moving upward or whether the lift is coming downward. In as much as the speed is not changing, it's going to have no effect on the weight of the body or on the entity inside the lift. So the weight that will be taken of the recorded of that body inside the lift will be the same as that which will be recorded if the body were to be outside of the lift. If the body were to be what? Outside of the lift. Okay? So the second condition is this. The second condition is if the body were to be accelerating, if the lift was going up with an acceleration, with a particular acceleration, if the body is going up, the body usually feel heavier. So if you are in a lift, for example, and you are going up, you will feel heavier because of this reason. The reason is that your body, the lift is moving with a particular acceleration, then coupled with the weight of your body. So there is an acceleration that is going against gravity, and then there is a force of gravity trying to pull you down or push you down back or push you back down. Is that okay? So what will happen is that FR will be the weight of that body plus the mass times acceleration due to gravity, the force that is pushing on you inside that lift, so that F recorded, the weight that recorded that body will be mg, which is W, plus ma. Is that okay? Hence, the body will feel heavier. The body will feel heavier. Or for the human, you will feel heavier. And here, the body will feel its normal weight. Is that okay? Then the third condition is this. In the third condition, the body, the lift, is now moving down. So the first condition, the body is moving, the lift is moving at uniform velocity. The second condition, the body, the lift is going upward with a particular acceleration. So, and now the third condition, the body is moving downwards. So, in this second condition, whether the body is moving with a velocity, with an acceleration that is greater than that of acceleration due to gravity, or less than acceleration due to gravity, the same condition holds. The body feels more weight than its normal, all right? But in this case, where the lift is descending, the lift rather, is coming down, in that condition, there are two possible events, or in fact, three possible events. The first possible event is this. Is it that the lift is descending with a velocity that is less than, with an acceleration that is less than that of acceleration, than that due to gravity? Is it that the body is coming with an acceleration, coming down with an acceleration that is less than that of that due to gravity, or it is coming down with one greater than that due to gravity, or the body were to be falling freely, the lift were to be falling freely. So those are the three possible conditions when the lift is coming down, and these are the three conditions that are possible that you can be possibly tested in an exam. So in the first condition where the body is descending, where the lift is descending with an acceleration that is less than that of acceleration due to gravity, what will happen is this. The F recorded will be equal to, because in this case, the force that will be pushing on that body, because the acceleration the acceleration of the lift is less than acceleration due to gravity, the force that will be acting on that body will be less than that of acceleration due to gravity. So the net force felt by the body will be the acceleration due to the weight, the natural weight of the body, minus the force that is acting on it, that is pushing it. So we have FR, the F recorded by that weight balance will be what? Will be mg minus ma. Is that okay? So m is common, so m into bracket g minus a. So this is what will be recorded by the weighing scale in the lift. So, and in fact, the body will feel lighter. So that's the condition of the body. So if you're in that elevator that is coming down, you will feel lighter. So if you have ever noticed in a condition, in fact, if you have been in an elevator before, you will notice that that condition does exist, or that condition does happen. So then the fourth condition is this. So we said the body is descending now. Here, it was descending with an acceleration that was less than acceleration due to gravity. What if it was descending with an acceleration that is greater than acceleration due to gravity? In this case, that force will be greater than what? Than the weight of the body. So F recorded will be equal to what? That force minus the weight of the body. That will be the F net. That is the net force on the body. So FR will be equal to what? Remember FR I said is the weight recorded on the weighing scale will be what? MA minus MG. Is that okay? Why? Because at this point, the acceleration is greater than that of acceleration due to gravity. The acceleration by which the lift comes down is greater than that due to gravity. So you're going to have this condition. So this is the formula you are going to use. Now the fifth condition, which is the last one, the final condition, is if the lift were to be free falling. So if the lift were to be free falling means maybe the cables were to break. If the cables broke off and then the lift was just falling freely. So in that condition, the body will feel totally weightless. The body will feel totally what? Weightless. So, and why will it feel weightless? It's because the force acting on the body is exactly equal to the acceleration by which it comes down is equal to that of acceleration due to gravity. So FR will be equal to W minus MA, and MA will be equal to MG. So MA minus MG here will be equal to what? 0. So the body will feel weightless. Is that okay? I said that the reason why the body will feel weightless is because the lift is coming down by an acceleration due to gravity that is less, that is just equal to that due to gravity. All right, that will be it for this video. Do us subscribe to the channel if you have not already, and click the bell notification to get notified whenever I drop a new video, and so that you might not miss out on any other content that I post. And make sure to share this content with your friends that you think might need this concept. And remember that you ought to understand and not cram. God bless you.